Welcome everybody to today's webinar, Data Modeling to the FACE Technical Standard. We have with us today Bubba Davis, Nathan Flinn, and Chris Allport.
All right, hey, thanks everybody. Thanks for being here. And thanks to my co-panelists today. So I'm Chris Allport, one of the founders of Skayl. And I, once upon a time, was a software engineer. And then a few enterprising individuals dragged me into this thing called data architecture and proceeded to lobotomize me therefrom. And things that I used to find to be very concrete and understandable became very esoteric and philosophical. So instead of fighting it, I embraced it, and that's where I find myself today, an almost functional human being doing data modeling things. So I also have served as the chair of the FACE Shared Data Model Subcommittee, and I get to share all of this awesome privilege with my team over at the FACE Consortium as well. So excited to share these topics with you all today. Nathan?
Hey, I'm Nathan Flinn. I was a contractor for most of my career, and then I switched over to government, excuse me, about 6 years ago. For most of my career, I've been an integrator, and so I've experienced quite a bit of pain with integration across just a number of different programs for Navy and Army, a number of different system classes, and the problems are always the same. And a few years ago, I started looking for solutions. You know, how can we do integration better? And stumbled across FACE, and really some light started to come on when I started to talk with some of the SMEs in the FACE community. And so I really just pressed into that and have spent probably the last 3.5, almost 4 years now, just really digging into the FACE technical standard, experimenting with building data models and those kinds of things. And found that I really enjoy the data modeling aspect of it. I tend to geek out on that. So I guess I've come to be recognized a little bit as somebody who knows a lot about FACE data modeling, which is why y'all asked me to attend here. And I always try to look at it from a practical perspective, and I hope that that's what I can represent here today, which is really how do we apply it and why should we apply it, and those sorts of things. Bubba, over to you.
Thanks, Nathan. I'm Bubba Davis. I am the FACE Domain Interoperability Working Group Chair, big name for what used to be the Data Architecture Working Group. I am by training, a software architect, software engineer, so I do take a software-centric aspect into the FACE world. Just that's my training and what I tend to do. I've been involved with the FACE Consortium for a little over a decade, led several subcommittees, including when the data modeling subcommittee was part of the technical working group. I've been chair or vice chair of the DAWG since it was formed, and principal author of several editions of the FACE technical standard. So I've got quite a history of data architecture, not only specifically with the FACE technical standard, but in a former job in my career where we were dealing with data-centric interfaces for automation systems. So I've followed this data modeling, data-centric approach through industry, academia, so it's ubiquitous across many, many industries. And Sonia, I will let you run the show.
Super. So you can see we've got a great panel pulled together for you today. We're going to have some moderated questions to the panelists, and then we'll be having time at the end where we'll be answering attendee questions. So let's start with, if someone is kind of newly initiated, so they're fairly new to FACE data modeling, where would you all suggest that they begin? And I'll ask that of Chris first.
Sure. So as Skayl, we've focused a lot on data modeling and the need to manage data models. And we've heard from many different sources and many different capacities that data modeling is hard, right? One of the aspects of data modeling is hard is that there's a mechanical aspect. And once you get past the mechanical aspects and all of the challenges of driving the tools, well, then you get to the philosophical aspect or the logical and semantic aspect of actually constructing models that go together. So with that in mind, we've put out several white papers. We've recorded some podcast material, and we've tried to make it something accessible to the community. So I'd really just point you to one of our white paper from last year, which is called Just Enough Data Model. And that's really to get things started for you, fundamentally with an understanding. And then, you know, seek the other materials as appropriate.
Thank you, Chris. And Bubba, do you have thoughts on this as well?
So new data modeling practitioners tend to come in and they immediately want to grab a tool and start data modeling. And I think taking a step back, the open group has a very good overview of why we're data modeling, what the purpose is that is recorded. It's on their FACE website, so you can find that through a Google page. It's on the open group YouTube channel. It was actually recorded from a presentation one of our colleagues, Bill Kinahan, presented. And it gives a good overview of why we're data modeling. We're focusing on capturing semantics of data exchanged. We're not focusing on source code or algorithms, but really on documenting the data we're exchanging and setting that foundation for why we are data modeling is very important so people can start to understand and see the value in it. Otherwise, they tend to look at it as a task that is a lot of work without a lot of value, because the software engineer writing code doesn't necessarily see the value of developing those data models. So I would really recommend starting there. Some of the papers Chris recommended are excellent and will help build on that foundation. It's not a afternoon job to decide, I want to be a data modeler, to becoming proficient.
Thank you all. So,
Hey, Sonia?
Yeah.
Can I just amplify something that Bubba said?
Yeah.
So, you know, Bubba pointed to some really good resources, especially some of the other recordings. One of the things that we've heard is that some of the things that point to why we do data modeling isn't super clear from the technical standard itself. So while it does tell you how to do the data modeling, and it does explain some of the data modeling, it may not fully convey all of the richness that you can get from using a data model. It's kind of like if you were to go read the Ethernet standard, it might tell you how to implement Ethernet, but it's not going to tell you how to build some sort of a real-time strategy video game using it. So make sure you leverage other resources that the community provides and don't just rely on reading the technical standard.
Right. And related to kind of, I guess, where to get started, we have a question about somebody's inquiring, saying, is there a list of data model related tools? Does that exist? I know that FACE has a list of, FACE verified tools, but is there a list of data model tools out there somewhere?
So the FACE consortium, the only tool they recognize is the FACE Conformance Test Suite. They do publish a list of available data modeling tools and other tools on their third-party tools website. Those are not certified, endorsed, advertised by the FACE consortium itself. So there's several tools out there. Even industry members have built their own tools that they are not making available because they view them as a competitive advantage. But there are commercial tools available. I would start with the Open Group's third-party tools site, and that will go through and show you at least the tools that people are marketing through that resource.
Thanks, Bubba. So What are some of the greatest technical struggles that you all have seen programs face when either developing a data model or refactoring a data model to make it, to align it to the FACE technical standard? Nathan, do you have some experience in that area?
Yeah, absolutely. Through our efforts over the last few years of exploring and understanding FACE and what it can bring and how we can apply it to surface Navy ships, even a different domain than is typical, we went through and we shredded a bunch of ICDs to ask ourselves, does the current shared data model have coverage of our interfaces and those sorts of things to see if that would actually work for us. And generally, we believed it would. But I'll tell you, our biggest problem was that the existing interface documentation we have is just very, very dirty. There are just a lot of bad behaviors in the specifications that we have today. And so a lot of the existing legacy systems that are built to those standards have, picked up on that dirtiness of the interface. So an example just came to mind. There was a particular interface where they were concerned about bandwidth, and they didn't want to spend a full 8 bits on an ASCII character to send it. So they created a custom 6-bit mapping of just the portions of the ASCII character, alphabet, and whatnot that they use. And then at the same time, in the same change update, they made an update that actually made the number of a particular kind of message that they send go up by almost an order of magnitude. So they saved 2 bits a message, but then they sent 10 times as many messages. Just silliness like that happens all the time today. And then you consider the fact that each system has its own object model, even in the code. But then you have the standards themselves, the interface standards that have their own ontologies. And so there's a lot of this ontology misalignment that happens, where everybody in their own head, the designer of each interface specification in their own head has an understanding of the language that they speak, and they're all different. And there's not a lot of alignment. It's very dirty. And so when you're trying to align it then to the FACE standard, it can be a fair amount of work to actually do that. That's not the fault of FACE. FACE is actually trying to clean that up in their own way. And I personally like and advocate the way that the FACE Consortium is trying to clean that up. But it is a lot of work just dealing with all those legacy old interfaces and the dozens of different ontologies that are represented across them. Aside from that, I'll say right now, from a practitioner's perspective, there is a lack, in my opinion, of effective data modeling tools. We're just beginning to see those start to grow up, the third-party tools that actually enable the data modeling. And so the FACE technical standard, if you get into the meta model, there's just a lot of traceability and linkage that kind of magnifies the number of mouse clicks that you have to do to build a data model. I have described it as death by 1,000 mouse clicks on several occasions. And that sort of is a result of the way that FACE has structured it. I still believe that they have that traceability and it's purposeful. They built it in there for a reason, and it's useful. But there needs to be a new class of tools that rises up that allows that portion of the work to be more automated and easier for people to work with.
Thank you, Nathan. And actually, Chris, I know you have some experience dealing with technical challenges related to tooling as well as related to just the architecture itself. So maybe you can speak to that as well.
Yeah, so I think Bubba does as well. A lot of the existing tooling is built on top of existing UML-based tools or similar to UML. So in order to make your models look the FACE way or make it compatible to be properly exported, there's a lot of learning that we need to do as modelers to just drive the tool correctly. Well, how do I create an entity so that when I create the entity, it's exported as a FACE entity? How do I create an association? What if I draw this line, in one tool, I draw an association line, and in another tool, I might have to draw a trace line. And these are because of how we layer profiles on top of these UML tools. Now, it's certainly a very effective way to get tools out into the market, and all we have to do is adapt these profiles on top of these really powerful tools. But then there's another layer of learning that we have to do, and that's how do we decorate all of our boxes and lines so that we can get them to export properly and give us an actual data model. And I think Nathan was speaking to that. That's where we get 1,000 mouse clicks, because it takes that many more mouse clicks and just manipulations of those software packages to get the models in the right shape. Now, beyond that, once we're over this tool hurdle and we don't have to, worry about, am I writing, making the right click or putting the right stereotype on data, we do have to worry about connecting our data meaningfully. And there are a couple of places where documenting data, it's very different from typically of how we think about documentation. And that's really what we're doing, though, is we're building data models for the sake of documenting our interfaces, right? And it's first we have to have the entity model, and this is the collection of things we talk about in what we call our domain. And this is why we end up with these domain-specific data models, right? We put our aircraft in there, or our ships, or whatever our messages talk about, or our interfaces talk about. And then we use the relationships between those things to document all of our interfaces themselves. So I guess we have not only do we have the mechanics that we have to get over, we have to learn what we're doing in the data models. And subsequently, we're documenting data at 3 different levels, right? We come at this and we document data conceptually. So we start talking about, what is the abstract meaning of the data? And then we talk about this logical representation. And that's where we start talking about how do we measure these concepts. And I'll be honest, when I first started hearing about logical concerns, I had no idea what anyone was talking about. It's like, wasn't this all logical? It's software. And then we ended up getting down to platform concerns, and that's where we start talking about things that developers are more used to seeing. And even now, we get a lot of questions about things like Nathan was just describing about 6-bit strings or 6-bit characters. And that's yet another level of modeling that we don't capture, because that's an encoding, which is usually delegated to implementation. So we want to make sure that when we're doing our modeling, we're focusing on the right level of data, and we're not trying to drill down into how specific systems implement their data in order to transport it across the network efficiently.
Okay. Thank you, Chris. And I did get a comment from Gordon Hunt that there's a standardized UML face profile now available from OMG. So that kind of relates back to some of what you were saying a few minutes ago. That may be helpful.
Right, and I believe that we're going to start seeing more support from all of the tools across the board for that profile. My understanding, Bubba, please correct me if I'm wrong, is that they've all committed to implementing that profile so that we'll have a much more level user experience.
I know multiple vendors have committed to implementing it. I'm not sure how many. The FACE Standards Alignment Standing Committee is actually spearheading that effort with the OMG, but it's going to be an approved annex or extension to the UAF profile, and so it will start to become available with the tools rather than have custom extensions be required.
Fantastic. All right, so you guys just talked about a lot of the technical challenges and support that's out there. How about non-technical challenges? What are some of the greatest non-technical challenges that you found that programs face when they are trying to apply the FACE technical standard? Nathan, do you want to take that one?
Yeah, well, yeah, I'd be happy to start on that one. Really, it comes down to culture. And it's really pronounced within the Navy, which is where I'm working. The Navy has operations from space all the way to under the water. And so across the services, we hit more domains and we have more programs. And there's more interoperability required to fight the fight at sea than to fight in some of the other domains. We cover the whole globe. And yet, with all of that as the challenges, our culture is that we still build these stovepiped solutions. Every program is funded for just their requirements, and they're going to do that in a way that meets their schedule and budget objectives and their functional requirements that they've gotten through that whole process. And once they've done that, they're done. And they don't think about the future. They don't think about any programs or any other kinds of systems that they're going to integrate with probably in the future. If it wasn't a funded requirement right now, we're not going to think about it. And the thing is, that's actually way more expensive in the long run, even for individual programs, certainly for the whole Navy, because we end up redoing the same work over and over and over again. And it's not just about building the systems, but it's looking about the integration and the interconnectedness of those systems. Why am I integrating the same model number of sensor 2 different ways across 2 different programs? And, you know, it happens all the time. And we don't share our interface documentation. We don't share our our work products very well. It's a cultural thing, and we really have to overcome that because it's really, you're not going to see the advantages of open systems, open architecture, or these kinds of technical standards like FACE unless you get to the point that you're actually culturally willing to build a component in such a way that it's shareable with your sister programs. And that is just not incentivized today.
Bubba, I know when we talked about this earlier, I think you had an addition that you wanted to make on top of Nathan's point about culture.
Yeah, so I think one of the biggest non-technical challenge we have is expectations. If you go talk to the software developer writing code, they're going to ask you, why am I doing data modeling? It's a significant amount of effort, and I don't see any benefit. And from a software developer standpoint, that is true. When you're writing code, it's not a huge benefit. The data modeling is not intended to help the originating software developer. It's to aid the integrator. So the integrator can understand your interfaces, understand the interface being exchanged. So now they can work to integrate and build a system from these components without having to have intimate knowledge of with the developer of those interfaces. So we're documenting them in a way that will enable integration. And I always like to, my past experience as a software developer, if you have ever inherited a project from another software developer that has left your company or gone on to another project and you have to maintain their code, you will see the value of having a data model to describe those interfaces so that you no longer have to read their out-of-date comments or their out-of-date documentation or go take that developer to lunch to extract that information. So some of the expectations of why we're data modeling, it's an investment the company's making in the integration and the long-term support of those software components.
Yeah, absolutely. So we've talked about a lot of challenges, technical and non-technical challenges, but there's got to be something that you guys like about FACE and UDDL. So Chris, what do you like about it?
Yeah, thanks. So we've been at data modeling for a while, right? And we formed a lot of our initial ideas about what data modeling is when several of us worked together in the UCS working group. And there was so much amazing pioneering work that was done there. And we ran into some technical limitations of that approach, or technical challenges. And when FACE started looking at the problem, they were able to sort of build on the shoulders of giants, right? They could look at some of the problems and say, well, we're starting from a blank slate, and we can make changes and pivot around these things. So there were some technical challenges that FACE addressed that just made the workflow for data modeling and data architecture better. But what got me really excited was the commitment to building test tools and to formalizing how we build our data models so that we can actually run them against a set of checks and know if we have a good model. Now, it doesn't tell us if our model is good. If the logical construction of the model is good, we need other metrics for that, more subjective measures. But it does tell us if we have a structurally good model, and it tells us if our model, follows all of these different rules. Beyond that, FACE has provided the ability to apply the data model when we're validating actual software. And they've provided the conformance test suite that puts these things together, and it will tell you if the software being delivered conforms to its data model. And that, I think, as a provider, it makes me happy to know that I have a good check. I have an agreement between me and my sponsor that what I'm delivering, we have something that's very objective. It says, yes, this checks the box. But it also makes me happy as a taxpayer to know that when my government is procuring pieces of software, that they're getting what they ordered and what they put on contract. And it's verifiable in software. And we're not always relying on our acceptance test engineers to figure out, what are the tricks and how did did it meet the objective, the requirements, or did it sort of meet the objective or requirements? We actually have a pretty good test that it does meet those objectives.
Yeah, and I'll chime in with a couple things. I'll tell you what I really like about FACE is mediation-based integration. In every other effort that I've seen across the whole DoD, there is this thought process that I'm building a system, even if it's a system consisting of multiple components. I'm building the system, and I have the ability to define its language, and all of my teams and subteams and subcomponents, they're going to comply with the language that I specify, and everybody's going to be happy because of that. And this falls apart every single time because of the culture piece that I mentioned a little while ago. We're not incentivized to do that. So program 1 does that, and program 2 does that, but in a different way. With FACE, there is a formal acknowledgement that mediation is not only going to be necessary, but that because it happens so commonly, it should be the primary piece that we support. And if you look through the integration that happens, especially if you got long threads of integration where system 1 sends a piece of data to 2, and then 2 to 3, and 3 to 4. So 6 systems later, after this data has been passed, it looks completely different. That sort of thing happens all the time today. So when you look at it at that a system of systems context, you realize there's basically like 20 different languages being spoken in my system, and I've got to make sense of this. And if you look how that integration happens today, there are dozens of spots within the overall architecture where mediation is happening. It's just that it happens one-off in these ad hoc fashions where you create a wrapper here, create a wrapper there, put a little service in there to do some translation. It's not deployed in a common space today. It's not even commonly documented. Usually what happens is you've got an ICD that is insufficient. Everyone recognizes it's insufficient. They don't know how to fix it, and they know that the governing body that owns the ICD is moving too slow to support their program objectives. So they write a requirements document on the side, which is usually not ever shared, but it's going to tell you how you're going to translate from 1 to 2 to 3 to 4 to 5 to 6 as this data is flowing around the system. It's just slow and it's ad hoc, and the mediation becomes just part of the greater monolith the way it happens today. But with FACE, they've said, hey, let's support mediation. Let's just really support it as much as we can. And so they've provided a common place to deploy it, that kind of logic, and they've created a way through these data models, that brings us over to UDDL, but through these data models, a way of documenting the integration in such a way that a new breed of tools can be used to compare interface 1 to 2, and interface 1 to 3, and 1 to 6. Right? And so this actually allows you to cut down on the number of mediations that are happening throughout your system of systems. We're no longer going from English to German to French to Spanish to, Chinese, right? Why don't we just translate from English to Chinese, using a crude example. With FACE, those kinds of things are possible. They're configurable and they're changeable over time because that logic is removed from the applications and deployed in that central TSS layer. So I really love what they've done to support the mediation-based integration. And so what I like about UDDL is they said, hey, if we're going to describe these interfaces in a data model so that we have tools that can then be developed that will do these comparisons and allow us to perform the integration work as we move from one ontology to another ontology through this mediation process. They've said, what can we do to actually force teams to build models that are going to make that comparison easier? And so one of the things I've heard folks complain about the OCL checks and things, and I certainly have experienced some points where I was like, hey, I feel like I'm at a hard stop here. Can somebody help me? I don't know how to represent the semantics of this data field so that it'll pass conformance. I've run into those. I'm a practitioner. I've taken some really dirty interfaces and taken them through this process. But I'll tell you, through that process and having to think so deeply about what the data actually is and means and representing it in the structure of the data model, when these OCL checks come in and then check me on that, what it does is it actually forces me to build a data model the same way twice. And what it also does is it says, hey, if you've got two teams in different rooms that are looking at the same picture of integration, perhaps they're funded by different programs or something and they're not really talking right now, so they're isolated. They're going to have to build data models that actually structurally look similar. And that can be used by the tools to then compare and begin to automate some of that integration work, which we know has to happen later. So we're paying a little bit of a price as far as the data modeling. It seems harder up front because of UDDL and some of these checks that they have in place. But they're really important because it saves a lot of integration time later. I like both of those thought processes. Over.
Thank you, Nathan. That actually, a lot of what you're talking about, what both of you guys talked about, kind of leads us to, the long-term value. So other than needing a mandate, I know that folks may have, is there a long-term value to using a FACE-aligned data model? You guys have kind of, talked around that, but can you maybe, directly address that? And Bubba, I'll ask you first, since we just talked to the other two guys.
So I think one of the big advantages of using the FACE data architecture to define your interfaces is you get a well-defined, standards-based, machine-readable description of those software interfaces. And that allows you to integrate this with your tooling. We've talked about tooling several times. And the FACE technical standard doesn't mandate any tool. It actually allows industry to innovate in that space, because if we picked a tool, it would be the wrong tool for somebody. It might be the right tool for most people, but everybody's tool chains are different. This allows you to innovate, but using the standards-based approach divorces us from any particular tool and allows the integrator to accept data models and software components regardless of the tools that were used to develop them. And so using the face data architecture to describe those interfaces allows an integrator to take the different software components, understand their interfaces, and integrate them into a system to function and give them the mission capabilities that they need.
Actually, we had a question. Bubba, you might be the best person to answer this. Does the Face Reference Implementation Guide version 3 highlight kind of the benefits and the richness that can potentially be gained from data modeling?
It does, at least to some extent. The Reference Implementation Guide, and this is particularly for Edition 3, it's Volume 3. The FACE community split the rig into 3 different sections, and so Volume 3 is focused on data architecture guidance. And a lot of that is helping the practitioner understand and get started data modeling, understand if they think they've identified a new observable, what questions to ask to make sure that it really is appropriate to add to the shared data model, and how they can go through and start building their entities and associations and the right mindset to take as they tackle that. And so it does cover some of the benefits. It's really targeted to those people that are going to be implementing and using the data architecture.
Great. Thanks, Bubba. And Nathan, did you have more thoughts on long-term value of face-aligned data modeling?
Yeah, well, as you mentioned, I kind of danced around it a bit before. There's a payoff here when we implement an architecture that actually supports the work that we do during integration. Let's stop pretending that we can achieve perfect commonality and doing that by inventing a new standard every few years. So the solution to our lack of standards alignment for these 17 standards is we'll create an 18th standard. It happens all the time today. And then new data definitions, new ontology, all that. We've seen this happen for decades. Let's stop doing that, and let's instead implement an architecture across our whole system of systems, across the whole Navy, across the whole DoD, that allows us to create clean and data-centric interfaces that are more easily understood, that result in more portable components, and let's put processes, tools, and guidance in place that allows us to create these portable components. Right? We know that when, as I mentioned in my previous example, if you got 2 teams working in a stovepipe way and they're not really talking, the solutions are going to be different. But if you require them to build data-centric interfaces and applying, UDDL and some of the checks that they have in place there, you're going to have models that look similar. You're going to be able to identify that I can use your component to drive my interface. That's savings right there. That's portability. That's opening up the field for competition, even between different components designs that are out there. So enabling all these different things that I've mentioned, the clean interfaces, the data-centric interfaces, making things more understandable, more verifiable, more leverageable. These are all the things that that the FACE Consortium has worked towards doing, but they enable the concepts of MOSA, which is I want to enable competition. I want to have systems that adapt well over time. I don't want it to take 2 years to integrate systems that I already spent 2 years to build in my little stovepipes. I want to be able to take those systems and integrate them in days to weeks. And if we really start to enable and think about the integration challenge, and this is, again, I'll heap some praise on the FACE Consortium. We really have this in the focus. If we keep that in piece of it in focus, there's just a huge payoff that comes. And at the same time, mediation is not the enemy of standardization. So another thing the FACE Consortium has done is, building out a shared data model, which is the beginnings of commonality of these interfaces. And so just through the process that they've developed and that they're currently engaging with, though it seems a little bit hard to work with at times today, as the tools come available, there's, I believe, going to be a huge payoff when we're no longer developing the same integration code in the 100th different way, Instead, we've got integration code components, designs, and documentation that can be reused and leveraged. There's going to be a huge speed up and a huge savings that comes, I believe. Over.
Great. Thank you. That's a good way to summarize. So before we get to the attendee questions, so attendees too, if you want to put any additional questions into that Q&A piece, we're about to get into that. But real quick from each one of you, if you guys can give sort of some short and sweet advice that you would give to a program that was tasked with either developing or with refactoring a face-aligned data model.
Yeah, I'll say start small and get started right away. I mean, don't expect to study that FACE technical standard and read it through 20 times and understand it. You're going to have to learn by doing, and certainly collaborate with the others in the community. But start small, and don't let perfect be the enemy of good. If you take an interface and you model 90% of it, that makes sense, but you still don't know how to data model the other 10%. I mean, you went from 100% dirty to 90% clean, right? That's an improvement and an advancement. And I, for one, would be willing to take that. And if you think about it like that, where the hard points are, ask for help. Where the easy parts are, keep going and making progress. I think that quick implementations are possible, even with FACE data models.
Chris?
Sure. Don't be afraid to make mistakes, right? So I think building upon what Nathan said, start small, but don't expect that you're going to build the perfect model the first time. And once you understand, because you've built some model, you've documented some interfaces, once you understand how it couples to your system or not, you understand you have a lot of flexibility to fix your model and improve it over time. So just get started.
Bubba, you want to round that out?
Sure. Chris and Nathan have excellent advice. I agree with everything that they've mentioned. There is a concept in the FACE data architecture called the domain-specific data model, or DSDM. I would highly recommend you seek out and see if there are DSDMs that cover your domain or cover part of your domain. Can greatly give you a running start and provide you with a lot of existing content you can reuse. I'm big on efficiency, so if you can reuse these existing data models that someone has taken the time and effort to build a DSDM, and you can use that to elaborate your interfaces, you are, one, saving yourself a lot of time and effort, and two, you're using an existing product that's going to make integration even easier.
Fantastic, good advice. All right, so reminder, just go ahead and put your questions into Q&A, and we'll go ahead and get started. Should we try to build a data model and have questions later? Should we try to build a data model and have questions later? Would the panelists be willing to provide contact information for the questions? So what I'll do, Jeff, thanks for your question. And what I'll do is I'll check with them, and we can include that since we're recording, when I send you the link to the video. Any one of the three of you who's willing to do that, I can be sure to include their email addresses. Another question, I'm fairly familiar with the 2.1 standard, but I haven't really touched 3.0 yet. What are the major changes, and what changes can we expect to see in the next version?
You want to take that, Bubba?
Sure, I'll take a swing at it. The biggest difference between the Technical Standard Edition 2.1 and the 3.0, and there's several more minor differences that happen, but the biggest difference with the data architecture is we went from projection-based mechanisms to specifier interfaces to a selection-based mechanism. And so we went from getting a interface definition or a view based on projecting individual elements from various entities and associations to using a more SQL-like language to select those. And it allows you to get more specific and make sure that you're following the correct relationships between your entities as you build those up. So there is a significant difference between 2.1 and 3.0 in how the views are created. We use a query and then a template where a query defines what data is being packaged together, and the template really tells how it's being presented. And so it allows flexibility in how that data is presented. You could have multiple packaging of that same type of data to go over the interface. That is definitely the biggest change. For the next edition, there's tentative plans for a FACE Technical Standard 3.2. This is more relaxing of constraints or bug fixes to issues that have been noticed in 3.1. The DAWG is working on proposals for a FACE 4.0 or UDL 2.0 to do more sweeping changes. Really, most are focused on usability. If we can simplify the data architecture, that's the main focus, but there's a variety of different proposals that are being considered. None of those are settled and decided yet.
And members of the FACE Consortium are welcome to submit proposals to be worked by the DAWG as well, right, Bubba?
Absolutely. We will, if you've got a good idea, great. If you've got a good idea with a potential implementation, even better. If you get that to the DAWG and the language subcommittee and we can put you in touch with those leads, they'd be more than happy to get you involved.
We have another question actually related to FACE 2.1 versus later versions. What recommendations do you have for integrating FACE 2.1 UOCs with FACE 3.1 UOCs using data models?
So I think it's important to realize the data model is just describing the semantics of your software component. So a FACE edition 2.1 UOC and a FACE edition 3.0 UOCs, there are slight differences in their software interfaces, and the integrator will have to come up with a strategy for making sure the right interface is presented to those, but inside that TSS, that information flows appropriately. From a data model perspective, it's just documenting the semantics of that data. And so from a data perspective, I don't see a huge barrier to doing that integration. There is some software integration that has to happen, but at its heart, the FACE Technical Standard is a software integration standard. It's based on software components and how to integrate them. So integrating edition 2.1 and edition 3.0 components is definitely possible.
Great. What is the risk of unchecking some of those CTS enforcement rules boxes? For example, observable and entity uniqueness. Bubba, do you have a response on that by any chance?
Definitely. So there are two conditional constraints in the FACE Technical Standard 3.0 and 3.1. We refer to them as the single observable and entity uniqueness constraints. And you do not have to check those as part of the conformance process. As a UOC developer, I highly recommend you do, because if you do not check those characteristics, you effectively are allowing yourself to embed semantics in role names in your data model. And we've put a lot of effort in the FACE data architecture to prevent that. There's a strong mathematical foundation behind the data architecture, and these two constraints are key to that. And so from a software developer, I think it's key to turn those on, make sure you're properly documenting your semantics and not relying on using a role name and just an English text phrase to portray semantics. And I know Nathan and I've had some conversations. He's got another perspective from an integrator's point of view.
Yeah, absolutely. First, I agree with everything Bubba said. I think you should keep the check boxes on. Now, I will tell you, as an integrator, when you're bringing together multiple data models built by diverse groups and trying to refactor them into a DSDM, and hopefully, as Bubba mentioned before, you started with a DSDM somewhere. You know, pick one of those to reuse, whichever one has the most or most meaningful content to you. But as you bring other components into your integrated system of systems and you're encountering data models built by other groups, sometimes it's hard to refactor these together. And so you have to understand what we're trying to do with those, or at least part of what we're trying to do with those conformance checks is ensure that the semantics structurally are expressed the same way if you're talking about the same thing. That allows the comparisons of those data models. So as you're doing those comparisons, if there's a point where you said, you know what, I'm not going to let perfect be the enemy of good. I really don't know how to express this one semantic concept for this one field of my 10 fields. If I don't know how to express that one, so I'm going to express the 9 very well, and this one, I'm going to map it to, you know, a placeholder or something, or I'm going to have a little note in the description that says, hey, I'm not completely sure about the semantics here, but this is the best I can do right now, right? So we went from 100% dirty to 90% clean, but we still have that 10% dirty. That 10% dirty, really, when you're comparing those data models and trying to integrate by leveraging the interface documentation, the way those tools are likely going to work in the future, you're just going to have more possibilities that are presented to you. Whereas before, you might be able to say, I know exactly how these two models relate, and it's a process that can be automated with tooling because you've got 100% clean interfaces. When that other 10% is now dirty, there are going to be some questions that the tools have and say, hey, this could be talking about that, or it may also be talking about that. So you're really just expanding the number of possible options and choices that would be presented to you during integration for how these two ontologies relate to one another. And, you know, worst case is for that one field, you may have to fall back on manual integration. We do 100% manual integration today. So again, having 90% automated integration perhaps, or at least being able to not automate portions of that 90%, I'll say it that way, versus not being able to automate any of it. Again, we need to not let perfect be the enemy of good. So keep the check boxes checked so that you know where your model's failing. Look at the failures, try to resolve them in an effective way. But if you absolutely can't or don't know how, I would say don't let perfect be the enemy of good. Make notes and say, I don't know how to model this correctly, but we'll come back and we'll fix it a little bit later. That's perfectly okay, especially when you look at the system of systems perspective. I might be bringing a component in. I only need to use 30% of the fields because it's all my particular integration, you know, my funded integration, all that's needed. So if you let that be an enemy, you know, perfect be the enemy of good, and you say, I'm not going to deliver, I'm going to throw face away. There are cases where you may not have even needed that 10th field in your overall integration effort, yet you threw away the entire integration framework because it felt like it was too hard. So again, don't let perfect be the enemy of good. Keep the boxes checked, but just understand, in my personal opinion, it's okay if you hit some tough spots to go ahead and deliver with a little bit of dirt still in your interfaces.
All right. Thank you, Nathan. We've got just another 2 minutes left, so I'm going to try to get through these last few questions fairly quickly. Are there any examples of a small but fully developed data model for a message or component that spans the layers of abstraction?
So we have some data models that we provide and we can provide as examples. So if there isn't something else available, Skayl's happy to provide something. I do believe that the Balsa data model is fully elaborated, so folks could get a hold of the Balsa data model and look at that as well.
And they would get that through Face Open Group.
Yeah,
I believe that's only available to FACE Consortium members today, but they're working on making that publicly available.
Okay, thank you, Bubba. Great. Another question is, what are the data modeling principles that a modeler needs to understand when transitioning from object-oriented data modeling in, for example, UML to data modeling in FACE?
with 1 minute left, huh?
Yes.
So I think that the biggest thing to remember when you're doing object-oriented modeling, you're modeling software. we're modeling with a face data architecture, the semantics of the data you're passing across a software interface. It's not necessarily the structure, because you can data model only at the conceptual level. So it's the concepts you're exchanging. You further elaborate that with the logical representations all the way down to platform structures, but you're really documenting the semantics of that data and only what's exchanged over the transport services interface. You're not getting into the typical UML models, which describe your software components and their control flow, their activity diagrams, sequence diagrams. Again, it's only the semantics of the data.
Thank you, Bubba, and you managed to do it in a minute. Do you guys have any last words that you want to add within the next few seconds here?
I'll just reiterate my thanks to Nathan and Bubba for being here to help us out today. Sonia, thanks for moderating, and just thanks to all the attendees for taking an hour out of your day to spend with us. I hope you found the content today useful, and we will be happy to continue the dialogue with you as you get deeper into data modeling.
Thank you all. We've got additional webinars coming out, and so information will be coming out for that. For July, we have another webinar coming up, and I think there's going to be an email coming out about that this week as well. So, thank you all. Have a great rest of your afternoon.
Thank you.
Take care.
Thanks all.